Hello, Professor. Hope you are doing well. This is Prashant Gajjala explaining you in brief about Chapter 10 Process Implementation with Executable Models. This slide describes about introduction of process implementation with executable models. In this chapter, process implementation with executable models appears to guide readers through the process of transforming conceptual process models into executable ones, specially using the BPMN language. This means a conceptual process. Models must be systematically revoked into executable process. Models to be interrupted and automatically deleted by software systems such as business process management system. The contents covered are: number 1, identify the automation boundaries; number 2, review manual tasks; number 3, complete the process model; number 4, bring the process model to an adequate guarantee level; number 5, specify execution properties. Slide 4, 5-step method. In this chapter, we propose a 5-step method to incrementally transform a conceptual process model into a executable one using the BPMN language. As part of this method, we also show how to make use of two other standards complementary to BPMN: the case management models and notations, and the decision model and notation. The steps are: first one, identify the automation boundaries; second one, review manual tasks; third one, complete the process model; fourth one, bring the process model to an adequate level of guarantee; and number 5, specify execution properties. Through these steps, the conceptual model will incrementally becomes one. This slide describes process implementation steps. Define objectives and scope. Identify key stakeholders. Develop executable models. Testing and validation. Implementation and planning. Execution and monitoring. This slide describes identify automation boundaries. A conceptual process model does not difficult to describe how each process should be implemented depending on its nature. A task may not easily be implemented automatically, or it may not be possible to implement it all via BPMS. So the basic principle or the guiding principle is not all process can be automated. Based on this principle, establish which parts of your process can be coordinated by the BPM is one which party cannot. So the input is the concept of model of the business process. So three types of tasks are designated: this are automated, manual, and use it automated means. I have performed BPMS itself by external service manual performed by the process particularly. Users are performed by the participant with assistance of the work list handler of BPMS or an external task list manager. Now we have reached the process implementation in the BPM cycle. We have now concerned with the executable process. This can be used to the runtime to process new business cases process, identification through process architecture, and then process discover as it is a process model. Then next step is process analysis. This insights on weakness and their impact, and the next step is process design to be procedure model, and then process implementation executable process model processing monitoring confirming and perform insights. So this is the explanation of the process implementation in the BPM life cycle.
Notation: the distinction between the automated manual and user task is captured in BPMN via specific markers on the top left corner of the task box. Manual tasks are marked with hand, while using tasks are marked with a user icon. Automated tasks are further classified into the following subtypes in BPMN. Script: if the task executes some code internally to the BPMS, this task can be used when the functionality is simple and does not require access to an external application. Example: opening a file or selecting the best quota from the number of suppliers. Service: if the task is executed by the external application which exposes its functionality via service interfaces. Example: check stock availability in our business rule. If the task triggers a business rule to be executed by the rules engine externally to the PPMS, the rule for approving a loan. Send: if the task sends a message to an external service, example request raw material from supplier. Receive: if the task waits for a message for an external service, example get shipping address. These markers apply the task only, they cannot be used on sub process since a sub process may in review manual task. Once we have identified the types of each task, in the second step of our method, we need to check whether we can link the manual task with BPMS. Goal: check whether the manual task can be linked with BPMS. The principle driving these steps is if the task cannot be seen by the BPMS, it does not exist. So we either find a way to support manual tasks via technology or alternatively we need to isolate these tasks and automate the rest of the process. There are two ways of linking a manual task to a BPMS. We implement it via user. First one, implement as a user task. Second one, implement as a automated task. Implement as a user task. If the participant involved in the manual task can be notified the PPMS of the task completion using the work list hardly of the PPMS, then the manual task can be turned into a user task. For example, a warehouse worker performs task retrieve product from warehouse, could check out a work item from the work list to indicate the task is being worked on. Manually retrieve the product from shelf and then check in the work item back into the PPMS engine. Alternatively, checkout and check-in can be combined in a single step by which worker notifies the work list order of the completion of the task. Complete the process model. Once we have established the automation boundaries of the process and reviewed the manual task, we need to check that our process model is complete. Main goal: establish the process model is complete. Two principles underlie this step. First, exemptions are the rule, and second, no data implies no decisions and no task handoff. Often the conceptual process models neglect certain information because modelers deem it irrelevant for the specific modeling purpose. They assume it is common knowledge or they are simply not aware of it. Depending on the application scenario, it may be fine to neglect this information in a conceptual model. However, information that is not relevant in a conceptual model may be highly relevant for a process model to be executed. You may be surprised about however early expectations are captured and conceptual process model is a practice. Thus, this majority of the case such as model will require to completed with the aspects before being executed. Looking at the second principle in this step, we also need to specify all electronic data objects that are required as input and output by the tasks of the process. Exceptions. Often a conceptual process model neglects certain information because modelers deem it is irrelevant for the specific modeling purpose. They assume it is a common knowledge or they are simply not aware of it. Depending on the application scenario, it may be fine to neglect this information in a conceptual model. However, the information that is not relevant in a conceptual model may be highly relevant for the process model to be executed. In the majority of cases, a model must be completed with the aspects concerning exemptions to make it executable. Data objects. Purpose. All electronic data objects that are required as input and output by task of our process need to be specified. Rationally, data objects are often assumed to be executed in a conceptual model. In an executable model, where a software engine has to run the model, they need to made explained. Each data object needed by the BPMS engine to pass control between tasks and to take decision must be modeled. The fourth concept is granularity enhancement. Task is a conceptual model may not be the right level of granularity for implementation. They may be either to be abstract, in which case we need to decompose them, or to deadline in which the case should be aggregated. For example, two consecutive tasks assigned to the same resource are candidates for aggressive in a similar way. If a task requires more than one resource to be performed, then it is too core grand. We should then decompose into grain tasks such that this can be assigned to different resources. A specific case on ad hoc sub-processes which are difficult to be defined in terms of the order of the task. Within the sub-process may be implemented using the case management model and notation. A language completely to be BPMN. Guideline principle. A BPMS adds value if it coordinates handoffs of the work between resources. Bring the process model to an appropriate level of granularity. Refer the details to make the model more IT oriented. Specify execution properties. Define properties necessary for execution, ensuring the model is ready for interruption by the BPMS. Consider aspects such as decision making and case management. At the end of the fourth step, we obtain to be executed process model. A process model that contains the right elements and it is an right level of guarantee to be automated with a BPMS. However, this model is still technology agnostic, that is, say it independent for the specific BPMS technology. We will choose for automation, such as software engineers may be supported by process analytics in the incremental transformation of a conceptual model into a top executed model. They are required to obtain fully executable process model. More specifically, these properties are variable messages, signals, errors, and their data types. Data mappings, services detail for service, send and receive tasks, and for message and signal events, course impacts of script tasks, participant assignment rules and the user interface structure for user tasks, task event and the sequence flow expansion and other BPMN specific properties. DMN. Sometimes the conditions that allows a process instance to be rotated towards one or another path in the model can be quite complex. OMG has developed the decision model and the notation standard, which can be used for the specifying business rule. DMN provides three parts for the specification of business rules. First one, the decision requirements graph DRG, which describes how data is propagated between the different decisions. Second one, the simple expansion language to be define how values are executed from the variables, and third one, decision table. DMN table. How to DMN table works here is an example of table. Each table has table name that is right here. In this example, we have to specify hit indicator. Whether we want to uniquely identify one role or if several can be chosen indicator size. If at least one of the rules has to apply or whether it is also possible that none of the rules. Priority indicators says which rules to choose first attributes are shown as different columns. The blue color there is an annual income and loan size that are relevant for the grade output. Here is a single output attribute that is called grade fact and range grades can be take to read this table as follows. The rules with the priority is the role in the row referring to an annual income in the range from 0 to 1000 and the size from 0 to 1000. Corresponding grade is very good. The second row is referred to as we have an annual income between 250 and 750 larger. 4000 to 5000 considered to be an good. This way we can read a table unique applies. We choose the first rule according to the priorities that we define to determine the output. Benefits of using executable models: increased understanding and clarity, improved communication among stakeholders, enhanced decision making, risk mitigation and analysis, times and cost saving. Thank you. Signing off, Prashant Gajjala.